In this video, we're going to learn about atomic theory. The learning goals for this video include the postulates of Dalton's atomic theory and using his atomic theory to explain the laws of definite proportions and the law of multiple proportions. We will also describe the three subatomic particles that compose atoms, define isotopes, and give examples for several elements. So these are the list of Dalton's postulates in his theory. The most basic one is that matter is composed of exceedingly small particles called atoms, and that each element is only consisted of one type of atom, and that all elements are different from each other, and that a compound that consists of two or more elements combine in whole number ratios to form compounds. And mostly, when you've heard in physics, is that matter, which is atoms, is never created or destroyed, but just rearranged. We're going to look at each of these individually. So the first three together really explain that elements are composed of extremely small particles called atoms. All atoms of a given element are identical. They all have the same size, the same mass, and the same chemical properties. The atoms of one element are different from atoms of all other elements, so they are unique. But let's say, what is an element? An element is a pure substance from which all other things are built that cannot be broken down into simpler substances. Over the centuries, elements have been named for planets, mythological figures, different colors, geographic locations, famous people, people who invented them, universities where they were invented. There are a variety of different names. And a complete list of all the elements and their symbols are found in the textbook and, of course, on the periodic table. So, for example, is carbon. Carbon has the symbol C. It can be arranged in different ways to give different types of carbon. So two forms are diamond and graphite that have been known since prehistoric times. Diamond carbon atoms are arranged in a very rigid structure, and it's very hard. The other form is graphite, which is a different arrangement of the carbon atoms, and that substance is much softer. So all atoms or elements each have a name, so they're usually a one or two letter name. If it's given one letter, it's capitalized. If there are two letters, the second letter in the name is not capitalized. So if you see two capital letters together, like you see here with CO, that means there's two different elements, carbon and oxygen. You will need to know the atomic numbers 1 through 20 plus a few others. I think I have them listed here, and off of your periodic table. But of course, you can always look at this periodic table as well. So some of the ones that you're familiar with: hydrogen, lithium, carbon, nitrogen, oxygen, all the ones you're familiar with, through 1 through 20. A few others such as copper, gold, silver, zinc, uranium, plutonium that you should be familiar with. The next part of the text runs through the history of the atomic structure. I'm not going to go over the history here. You can kind of read that up on your own. But I will go back to Dalton's atomic theory. So now we have all these elements. How do we make compounds? Compounds are composed of one or more element that's put together. So in any given compound, the same types of atoms are always present in the same relative numbers. So this is called the law of definite proportions. So thinking about something you know that water is H2O. There is always two hydrogens for every one oxygen, and you can see this in this little picture here. So the four hydrogens come together with two oxygens to make two water molecules. And whether water is in a bottle, water is in the sink, water is in the ocean, water is any place, if it's water, it is two hydrogens and one oxygen. And this is called the law of definite proportions. So Dalton's theory also extended to chemical reactions. What happens to these atoms when they form compounds? Nothing new is created. It's just the way that they are put together that makes it a new compound. So if you have two different kinds of starting materials, such as shown here is the green balls and the little blue balls, when they come together at the end, you still have the same atoms that are there, but they're put together in a different way. So looking at something again that we know, we have carbon plus oxygen giving carbon dioxide. So the black ones here are the 4 carbon molecules. Here are the 8 oxygen molecules, because oxygen is always in the O2 form. And when you put them together, you end up with 4 carbon dioxide molecules. And you can see that everything is accounted for. And if you look at the ratio, the mass ratio, you'd see in carbon dioxide, the ratio of oxygen to carbon is always 2.66 to 1. So this is the mass ratio. So the weight of the, I shouldn't use weight, but the mass of the carbon, of the oxygen, is more than the mass of the carbon. So sometimes you have things come together in different proportions, and that is the law of multiple proportions. atoms of two or more elements can combine in different ratios to make different compounds. So we just looked at carbon dioxide. You can also look at carbon monoxide. So now we only have carbon and one oxygen, and that ratio now is 1.33 to 1. So the atom ratio is 1 to 1, but the mass ratio is 1.33 to 1. And this is the law of multiple proportions. So some things, like we said, carbon and oxygen can come together to form carbon monoxide, carbon dioxide. Water is one example of hydrogen and oxygen. Peroxide is another example of hydrogen and oxygen. And nitrogen and oxygen come together to form 5 different types of compounds, from just NO, NO2, N2O, N2O2, N2O5. I'm not going to go into the names of all of them now, but you can see there's getting to be a lot of different combinations. And these arise from different ratios of the two elements. So just summarizing, these are the laws, Dalton's laws. The law of conservation of mass, so nothing is created or destroyed, they're just rearranged. The law of definite proportions, that anything that has the same proportion is the same compound. And then the two types of elements can come together in different proportions to form different types of compounds.